All right, hello once again. This is Jeff Scott of Rankin Technical College. And as I've been saying on my ever-ending or never-ending quest to make things easier for people in the Rankin Technical College AWD 1000 Web Development Technologies and the AWD 1111 Database-Driven Web Development classes, I've been going through and doing a series of video presentations based on the ebooks by Mr. Flavio Copes. So far, I've done Mr. Copes' HTML book, his ebook, his CSS ebook, his JavaScript ebook, and I'm now about a quarter of the way through his ES5 to ESNext ebook. All right, so continuing on, tag templates or template tags, as it says, is one feature that might sound less useful to you, but it's used by lots of popular libraries. All right, so they're showing a couple examples right there. Now, there's absolutely nothing wrong with the example that they've listed. They're all totally fine. I just want to mention that one of the things that you oftentimes see template literals used for is if I decide that in a JavaScript program, I want to add a bunch of HTML and I want it to be formatted so I've got stuff on different lines, etc. In my code so it looks easier for me to read and understand. I can use template literals to do that. All right. But they go through this. I'm not going to run through that now. I've never used it. And I don't want to sit and read to you. All right. Destructuring assignments. As it says, given an object, you can extract just some values and put them into named variables. All right. So notice that when we're doing this, what do we have here? All right, we've got a person, and that person has a first name, a last name, an actor status, and an age. But what we want to do based on that is we want to destructure or only pull out what we need. So just the first name that we're going to refer to as name and the age. So this is going to hold only Tom and 54 as far as I know. You can do this on arrays as well. All right. In ES 2015, object literals gained superpowers. Now, what does that mean? That means that when you're doing this, let's suppose, for instance, when we did this one here, we don't have this, but let's say this said first name, last name, actor, and age. It's kind of what they have down here. If that's the case, if the key and the value have the same name, you only need to list it once. All right. Now, prototypes are the way that you used to do object-oriented programming in JavaScript. And you still see in a lot of legacy code, and there are still a lot of people who are very, very capable, good JavaScript programmers who still use this prototype with this. Now, what's kind of cool about prototype is you can prototype in different ways. One way you can prototype is you can after you've created your own class, which is their blueprint for your object, you can go back and with a prototype, you can add things that were not in there originally. Typically, too, you can also prototype so you can go and take some class that was built in by somebody else, or even a JavaScript class, and by using prototyping, you can add extra features and functionality into it. All right, the super we talked about previously. Dynamic properties. No, I've never used them. The for of we've talked about. For of, as far as I know, it says it combines the conciseness of the for each with the ability to break. Okay, that's fine. But I look at it with this as with that for of that it's something designed to let you iterate your way through collections. And collections are data structures, which basically are not primitive variables. Okay. It says here, notice the use of const that we've got here and we've got here. This loop creates a new scope for every iteration, so we can safely use that instead of let. The difference with for in is for of iterates over the values, whereas for in iterates the names. And until you've worked with this a little bit, it's probably not going to make a whole boatload of sense to you. All right. Next here we have promises, and we've talked about promises in the last lecture. And please, again, remember that eventually, and hopefully before the semester starts, I'm also going to go back through this book I bought. Not that one. That's not a book. This one. JavaScript Async. Events, callback, promises, and async await. I'm going to go through that entire book. All right. And I'm going to do notes on that one. I think it's going to go into more depth and breadth of coverage than what we're currently going over. All right. A promise, as it says, is defined as a proxy for a value that will eventually become available or not become available. Remember, promises can be resolved, which means, yeah, it became available, or they can be rejected, which means it didn't become available. But you've got your choice by using .then and .catch with promises to say if it did get resolved, we want to do what comes after the .then, and if it was rejected, we can do what comes after the .catch. They, as mentioned here, they are one way to work with asynchronous code. Remember, asynchronous code says that if you've got one or more lines of code, if synchronous code says if I've got 10 lines, I do line 1, then line 2, then line 3, then line 4, then line 5, then line 6, then line 7, then line 8, then line 9, then line 10. And if for some reason line 6, let's say, takes some time, line 7, 8, 9, and 10 have to wait until it's done. But with asynchronous code, if I've got an operation such as a file read or a database read, or if I have to go out to an internet site for whatever, all right, I can say that rather than the program having to stop and wait, I can tell it to go on and to resolve this request to go out to the internet or whatever when you can. In other words, when it's done. So, as mentioned there, promises are one way of dealing with asynchronous code without writing too many callbacks. And we talked in the last section that can lead to what's called callback hell. You want a little more on that, a very succinct little thing, go to callbackhell.com. Async functions use the promises API, or the promises application program interface, as their building block. Understanding them is fundamental in newer code, where you likely use async functions instead of promises. So, once a promise has been called, it starts in what's known as a pending state. I've called it promise purgatory. That means it has not been resolved and it has not been rejected. So it says the caller function continues the execution while it waits for the promise to do its own processing and give the caller some feedback. At this point, the caller function waits for it to be either resolved or rejected. But as you know, JavaScript is asynchronous. So the function continues its execution while the promise does its work. And I've given this kind of example before, and I am going to say it again. Just imagine, all right, that, one of the better examples I've ever heard of like the work of a promise is if you've got someone who's, and let's say an executive assistant, and let's say that he or she is working at their desk and they're creating a report for their boss, and the phone rings. All right, well, the phone rings and it's somebody they need to talk to, but they're smart enough to know that they can keep working on their project while they're on the phone with this person. Now they get done. Now the phone rings again. And this is an unbelievably important person. You can't do anything at all until you get done talking with this person. Well, in the first case, where you could keep working on your project even while you were talking with a person, you were more or less working asynchronously. In the second case, where you had to talk on the phone and could do nothing else until you were done on the phone, that was more or less synchronously. All right. In addition to your own code and library code, promises are used by standard modern web application programming interfaces. All right, so if you want more on fetch, which we will talk about in class, and service workers, which again we will, those are topics for the AWD 1111 class. All right. It's unlikely that in modern JavaScript you'll find yourself not using promises. So it says, let's dive right in. The promise API exposes a promise constructor, which you initialize like this. All right. So, is it done yet? New promise, resolve, reject. If done, okay, here is the thing I built. All right, resolve, work done. But if it doesn't come back, still working on something else, and you reject. So it says, as you can see, the promise checks the done global constant. When it's true, it's going to return a resolved promise because the operation is completed. If it returns false, it is not yet completed. So using resolve and reject, as mentioned right there, you can communicate back a value in the above case. All right. So it says previously they showed how a promise is created. Now let's see how it can be consumed or used. The dot then is basically what you want to have run if the promise was resolved. The dot catch is what you want to run if the promise has been rejected. I can't say it any simpler than that. You can also do what's called chain promises together. So a promise can be returned to another promise. It's kind of like in some software where you use the output of one operation as the input into the next operation. That's the whole idea of chaining, really. So it says a great example of chaining promises is given by the fetch API, a layer on top of the XHR or XML HTTP request API, which can be used to get a resource and then queue a chain of promises to execute once that resource has been fetched. So again, this would be the kind of thing, as mentioned previously, if I ever wanted to go out, for example, and I wanted to go out to an internet site to grab something. All right. The fetch API, as it says there, is a promise-based mechanism. Calling fetch is equivalent to defining our own promise using the new promise. And here's an example. So notice the status. It's greater than or equal to 200 and it's less than 300. It was resolved. So it returns something successful. Otherwise, it was rejected. All right, so you're telling it here to come out here and do the fetch. And based on that, you're telling it to do that status. Based on that status, if that succeeded, you're telling it to do this. Right there. If that succeeded, you're telling it to do that. If it failed at any time, you're saying request failed and you're giving it the error. So in the example here, as it says, we call fetch to get a list of to-do items from todos.json file. Running fetch returns a response, which, as it says, has many properties. And within those, we reference the status. Again, that's that value that tells us our hypertext transfer protocol status code, and status text, which is going to be okay if the request succeeded. It also has the JSON method, as mentioned right here, which returns a promise that will resolve if the thing is able to be converted into JSON. So given these premises, this is what happens. The first promise in the chain is a function that we define. It's called status. It checks the response status, and if that's not a success, it rejects it. But if it is a success, it's going to go on. Well, let's say it wasn't a success. So it returned a number that was not within the 200 to 299 range. So if that's the case, it's going to go directly down to the catch that's down here, and that is what is going to execute. On the other hand, if it succeeds, all right, if it did return something between 200 and 299, it calls the JSON function that was defined. It says since the previous promise, when successful, returned the response object, we get it as an input into the second promise. Again, like I told you, using the output of one operation as the input into another one. In this case, we return the JSON data that we promised. All right, so the third promise then, the input to that will be that JSON data that gets logged to the console. And if there were errors in anything up above, we've got the .catch. So it says in the above example, we had a catch that was appended to the chain. When anything fails, the control goes to the nearest catch down the chain. So if something fails here, it's going to go there. If something fails here, it's going to go there. Now, there's not really a whole lot to doing it like this because they're doing the same thing. All right. Inside of the catch, it says you raise an error. You can append a second catch block to handle that. All right. So we're throwing a new error here, but if there's a problem with that, we can catch that in here. Orchestrating promises, as it says right here, if you need to synchronize different promises. So in other words, this work, we get done with this, then do this. We get done with that, do that. We get done with this, do that. And if you've got a series of those, and they're all basically dependent upon one another, you can have a promise.all. As it says, when you do that, it allows you to define a list of promises and execute something when all of those promises have been resolved. And there's different ways that you can write this. Promise.race, as mentioned right here, runs as soon as one of the promises you pass to it resolves. And runs the attached callback just once when the result of the first promise has been resolved. Errors with this, as it says, if you get an uncaught type error, undefined is not a promise, it says make sure you use the new promise instead of promise. So you are creating a new object, a new promise object, so you need the new keyword. All right, I believe that this is a good place to stop. We're at 18 minutes, and we'll pick it up on modules in the next video.